Okay, so the other day, this is the only one that I think we did that I didn't quite finish with this group the other day. So we talked about that the component form would be 6. The first one is cosine of 270 degrees and 6, and the second one is sine of 270 degrees. What I neglected to do was actually finish solving it, which we're going to use our calculator to do. Okay? So I'm going to show you a little bit of a trick so you don't have to take your calculator out of radian mode to do this. Okay? So we should have already written that much down. Okay? All right. So in your calculator, I want you to check a couple of things with me. Go home. Okay? On the calculator, hit the home button. Not on the calculator, go home. Not go home right now. Okay? All right. Settings, and go to doc settings. You need to double check because math analysis has been messing with them. Okay? Float 6 and radian.
Can I please have Carl Chestnut to the office, please? Charles
Do you realize
Chestnut
lunch is
to the
over?
office.
People are crazy.
All right. All right, we good? Float 6 and radian. Click make default. Okay. You need to, and you want to hit OK to apply it to the scratch pad. You want to make sure you check that before you take a test. Okay? Then go ahead and come over here and grab calculate. Just so you know, if you grab this little triangle guy, sometimes they'll go in and they'll change the settings here. And sometimes so your float will be 6 on the first one, but not on this one. Okay? So you want to always double check because there's 2 hidden places for it. Okay? Float means how many decimal places you get. Okay? And so math analysis is getting annoyed by our 6 decimal places, so they go in and fix it to something else. All right? All right, so what we're going to do is we're going to type in. Remember, our calculator is in radian, but this problem is in degrees. All right, so here's how we're going to fix it so that we get a degree answer. So you do 6, and then we're going to do cosine. We're going to do each component separately. And then I'm going to type 270. And if you go underneath the pi, so hit the little pi button on the left-hand side. Do you see the degree symbol? It's right under pi. Hit that. That will calculate it in degrees, even though your calculator's in radians. So that, we need to talk about that answer. That means you take the decimal point and you move it 13 times to the left, which makes it 0.000000006. So it's basically 0 whenever you see that. Okay? And then we're going to do the other component, 6 sine of 270, and it's in degrees, and hit enter. That's -6. So what we would write for our answer, or what would we would be looking for multiple choice, okay, is, what did we say? We said it was 0.6, right? All right, so from there, I know we had done a bunch of them. I taught you how to do a bunch of them on the calculator versus doing them out by hand. What else do you guys want to talk about that we hadn't talked about the other day? 9, which one, D?
9D, yeah,
I'm getting rid of D.
okay.
So I'm going to just cross it out.
And then
12, we want to talk about number 12?
Yeah.
Okay. 9D, we're going to get rid of. It won't be there. Let me find 12, not that one. Okay. So, this one is really, really strange. Okay, so the first thing we're going to do on 12 is we're going to go ahead and graph it. So everybody grab that and get that graphed in your calculator. So I'm going to get rid of what's there. Remember to graph this. We need to we need to switch it to polar. So menu, graph, edit, entry, polar. And then for sine theta. Theta's under your pi. And then the other one you put in a 2. I'm getting it as big as I can, so. Okay. So the first thing I need to figure out is where I'm integrating to and from. Okay. And it wants a common interior. Did everybody get it graphed? Am I going too fast? Okay, so it wants us to find the area that's inside here. Okay. To do that, I'm just going to find the area of 1/2 of it. Okay. So whatever I do, I'm going to double the area. But remember, our formula starts out 1/2 the integral. So what's going to happen to the 2 and the 1/2? Cancel. Okay, now this one, I'm going to have to erase what I did on the picture because it's really the, oh, that was dumb. All right, oop. Let me just do that again. 2, and then it was 1/2, and we know we're going to cancel them. All right, we have to figure out our limits. Okay, so let's do that next, and then I will deal with the picture. So I know that this limit is going to go to where? There's something about pi over 2 there, but I've got 2 graphs going on, so I need to figure out that intersection point and to figure out what's going on with the intersection point there. How do we get the intersection point? Don't we set them equal to each other? I don't think it works on the calculator. You can try it, but I don't think it works because it's in polar. I think that only works when it's in, whatchamacallit, in rectangular mode. All right, so what am I going to do to move that 4 to the other side? Divide, so sine theta equals 1/2. So where is sine equal to 1/2? Pi over 6, and I don't really care about, it's also 5 pi over 6, and we can see it's crossing there, but I don't care about that part, okay? I just care about the pi over 6. So I know that this is pi over 6. And this one was pi over 2 up here. Okay, here's the problem. Okay, I'm going to try to draw it in there the best I can. So I'm going to use this blue color. So if I were to draw a line right from here to there, and this is what's hard to understand about this one. Okay, so the graph that's acting from pi over 6 to pi over 2 is that chunk of the circle, of the red circle. Does that make sense? Okay. And then you see, I blew it way up on purpose because it's really hard to see this little sliver. From 0 to pi over 6, the area of the graph that we need is that little chunk. Okay. So that means I have to set it up as 2 separate integrals. All right. So from 0 to pi over 6, I'm going to use the blue one, which was this first equation, right? It was 4 sine theta, and remember we square it as part of the formula, and d theta. And then we're going to add that. I'm going to put some parentheses out here so because my 1/2 technically should be outside the whole thing, but we end up canceling it anyways. From pi over 6, let me write it in red so you can kind of see it match up. So from pi over 6 to pi over 2, I'm using the other function, the 2 squared, d theta. And then at that point, I'd say put it in your calculator and integrate it. Okay. If you really want to do it by hand, you probably could, but it's probably more trouble than it's worth. So the big ones like that on the test are going to be on, or if they're going to be on the calculator. I'm more looking at your setup and can you put it in the calculator. Okay. All right, are there any others that you guys want to talk about that we haven't touched yet or that you want to do again? That's it? Which one, Marlette? Number 1 on the study guide or the multiple choice? Study guide? Okay. Go back and do number 1. Remember, I'm going to get rid of direction angle. We're just going to talk about magnitude. All right, so we're going to get rid of that part. All we want to talk about is the magnitude. When they give us a numerical one like that, all you're going to do to find the magnitude is you're going to square root of whatever the numbers are and square them.
Why don't you take the derivative?
Because there isn't a derivative to take.
Oh, there's no like x.
Yeah. There's no yeah, take the pass. Remember, you can, if it says like it gives you the position, it says find the magnitude of the velocity vector, then you take the derivative and plug the derivatives in. Okay? But if it gives you numbers, then you're just going to plug the numbers in. Do I need to keep going, Marlette, or you got it from there?
I got it.
Okay.
You do the one on the speed,
Number 8 on the study guide?
Mhm.
Yeah. Alright. Remember, speed is magnitude, right? So, we know we're doing magnitude, so this is kind of what Greg was talking about. Don't you take the derivative? Well, for this one, we do need to take the derivative. So, because it's in position, and it wants speed of the particle. So we've got to take the derivative to get to speed, because speed is off your first derivative. So, we're going to take the derivative of each one of them and square it. So what's the derivative of the x component?
Negative sine 5.
5
Negative
sine
5.
5t, right? Because we've got a chain rule. The derivative of cosine is negative sine. All right, what's the derivative of the y component?
3t squared.
Good. All right, what are you supposed to plug in? 3. So negative 5 sine of 15. Do not use degrees on that one. Okay? I think that's 27, isn't it? And then punch the buttons. I want to say we got 27 point something. Check it. Make sure we get this 27 point something. Because I think at one point we got 26. I think those that came Monday night, we got 26 and we were wrong. The parentheses were in the wrong spot on something. What is it? 42? 422? Is that what everybody else is getting?
I got 26.96.
26.96. Okay, I know that's a calculator issue. We're putting it in wrong that way.
I got 20.
All right, let's. Masato, what did you get?
27.19.
That's the right answer. Good job. All right, let's put it in together. Okay. So let's make sure it's a parentheses issue, I'm sure. Okay. So we had to put in a square root. So watch, because you got to really watch the parentheses on this, and then you put a parentheses. And if you want the negative there, you can have it. You probably don't need it because it's going to go away. Sine. But see how the sine added its own parentheses? The squared has to go on the outside of that whole thing. Okay? Plus, and then it was 27 squared, right? Have you switched the mode of your calculator, made sure it's in radian? Did you put the little degree symbol after the 15? But you shouldn't.
Wait, no. I didn't.
Okay. I don't know then. I'd have to actually look at it. If you want to bring it here, I can.
On the tangent line?
On the tangent line, there was only one that was on here, right?
Yeah.
And so if there is, it would be just like the one that's on here. Okay. You want me to do it? Which one was it?
I think it's 2 on the multiple choice.
2 on the multiple choice? Okay. Alright. And remember, the only thing I might give you is your, trig identities table. Okay? So you won't have any of the formulas, so you need to make sure you're good on your formulas. Marla, if you want me to look at that problem on your calculator, I can. Oh, okay. Alright. It helps if we put the right number in, right? Okay. So this one is weird, and I think it was somewhere probably in the day, or it was probably right, it was in our notes and we probably glazed over it a little bit. What you have to do on this one is you have to take the derivative, I'm using r because that's the name of the function, over the magnitude, the derivative of the magnitude of the derivative. That's how they get those denominators, okay? So it does it the vector of the tangent, so the tangent we know is the slope and slope means derivative, right? So let's take the derivative of the function, and then we're going to evaluate it at 2. So what's the derivative of that vector? 3t squared, 4t, right? All right, and then if I start looking at the magnitude of that thing, and I start plugging in the 2 into it, when I plug the 2 in, basically I'm putting it into that thing, right, and squaring it. So what's 2 squared 4 times 3 is what? 12, so 12 squared. And then 2 times 4 is 8 squared. All right, so I also need to plug the numbers in for the numerator. So we know that that number comes out to be 12. I don't know why I'm drawing such a big fraction bar. Let me erase that. All right, so if I draw, I'd have a 12 and I have an 8 in the top. Let's see, what's 12 squared plus 8 squared? 208. I gotta break that down. Look at your choices. It's either 3 or 13. Which one? 13, how many times? 16 squared is 16 is? 4 squared of 13 and 4 squared of 13. 4 goes into 12 3 times. And 4 goes into 8 2 times. So it should be this B answer, right? All right, are there any others that you want me to talk about? That's it? Derivative, right?
Yeah.
If we give you position, so it's the velocity or position velocity acceleration hasn't changed. It's just we're putting it in vector format. Okay. All right. So tomorrow your notes are due. They told me page 145 last period. Okay. So in addition to your summaries, okay, you also need to make sure your table of contents is updated for the last time. Okay. You've got a little bit of time. You can work on studying. I'd make sure I knew these problems, okay? Because we know that there's 13 on the test, right? All right. So I would make sure that you're practicing a little bit. If you need help on something, come ask me. If you want something stamped, come ask me. I'd be happy to do it for you. Okay. Oh, also, so you guys know, if you are able to help with snack bars next Thursday, we've got 2 going at the same time. So I need all hands on deck. Okay.